If you have any experience at all with programming, you have probably written lots of console programs. But how do you add color? How can you format your output to make it look good? Stay tuned, because we'll talk about all of that in today's video. Hello everyone, my name is Mike and you're watching Polymath Unlimited. In this series, we are learning the C++ programming language by building our own Sudoku game. In the last episode, we added a function to our program to check if a move is legal, and used that function to enforce Sudoku's rules. In this video, we will add some code to our program that will allow us to visually format the program's output. This will make our Sudoku game look less like a jumbled mess of numbers and more like an actual Sudoku game. To start off, we need to add another function to our program. This new function will contain all the code necessary to draw a Sudoku board by printing characters into the console. First, we need to declare our function's return type. We don't actually need this function to return anything, so we'll use a special type called void, which lets the compiler know that this function does not need to return any data. We'll name the function draw, and we will have the function accept a two-dimensional array representing a board state as an argument. Now, just to verify that everything is still working properly, we'll simply copy and paste the code from our game loop that draws the board into this function, and replace the code in the game loop with a call to our draw function. When we run the program, we should see that it behaves exactly as it did before. Now, we just need to modify the code in our draw function in order to get the output to look nicer. A good place to start would be to draw some lines on our board to make it easier to see the subgrids. We can add vertical lines by adding a vertical bar every 3 characters. So inside the x for loop, we'll check to see if x is 3 or 6, and if it is, then we'll print a vertical bar. For the horizontal lines, we'll add a similar if statement to the y for loop, printing out a line of dashes with some plus signs added to help blend the vertical and horizontal lines together if y is either 3 or 6. Now that we have some grid lines on our board, the next logical step would be to add some additional markers to make it easier to see grid coordinates. When the user is placing a number in a square, we specify the grid square with alphanumeric coordinates. So we want the numbers 1 through 9 to appear above the grid to mark the columns, and the letters A through I to appear to the left of our grid to mark the rows. We can mark columns by simply adding another cout statement to the beginning of the draw function. The rows can be marked by adding to the cout statement at the beginning of the y for loop. Note that we also need to add some additional spaces in some of our other cout statements to maintain alignment of the rest of the board. This char statement here is something called a typecast. In order for our computer to interpret a plus y as a character instead of an integer, we need to cast it to the character type. You can do similar things with all the other types in C++. For example, it is sometimes advantageous to cast an integer to a float type in order to avoid round-off errors in calculations your program performs. We'll point out other typecasts we use in our code and why we would want to use them if they come up. Now we have a nicely formatted Sudoku board, but it still looks kind of bland with just white text on a black background. Wouldn't it be nice if we could add some color? Luckily, this is pretty easy to do using ANSI escape sequences. If you're on an older system, this is where you might start running into compatibility issues. Mac and Linux systems should all support ANSI escape codes, and Windows 10 and upwards should also support them. However, if you're using an older version of Windows, some of the code we will write today might not work. In that case, you will need to include the windows.h header file and use some Windows-specific functions in order to change text colors in the console. I won't go into how to do that here, but there are plenty of resources on the internet that should be able to point you in the right direction. To use ANSI escape codes, we just insert them into our cout streams as strings. When the console receives these codes, it will interpret them and change its behavior accordingly. To send the code, we begin with the escape character, \033. We then send a single open bracket, followed by any arguments that escape code needs, separated by semicolons. The first argument we want to send is 38, which tells the console we want to set the text color. Next, we send a 2, telling the console that we want to use a 24-bit color specified by RGB values. Then we simply send the specific RGB values we want to set the text color to. Finally, we tell the console to format its text output according to our previous instructions by sending the M character, and voila! The text color should now change. Here, I have set the text color to red. The neat thing about ANSI codes is that they don't apply globally, only to text that we output after the escape sequence. This allows us to change the color of individual characters of text if we want to. We simply send another escape sequence before outputting to the console, and then everything we send to the console after that will have that color applied to it. If we ever want to reset to the default settings, we simply send an escape sequence with 0 as the only argument. Here, I have set the colors of grid lines and the coordinate markers to a gray color, and the numbers in the grid to the default color. Now that we know how to set console text colors, let's take it even further. Most of the time, you're not starting from an empty Sudoku board, but rather you have a set starting board that you are trying to complete. In order to differentiate squares that we start with squares that we are trying to solve, let's decide now that starting squares will have a negative value in our board array. Here, I have set the board to have starting values for some Sudoku puzzle I found on the internet. We'll need to modify our isLegal function for this change. Specifically, we want to make it illegal to modify a starting square. We'll add an if statement for that case. When checking other squares, we also need to add the ABS function when we read values from the grid. This is a built-in function that simply returns the absolute value of whatever we give it. Now, in our draw function, we need to print the absolute value of the number of the square since some of them will be negative. Let's also change the color of starting square numbers to green. We'll add an if-then-else statement that sets the color to green if the number is less than 0, or to the default color in all other cases. Let's also add another if statement that checks to make sure if the number we are drawing is not 0. If it's not, then we can print the number normally. But if it is, then that means the square is empty, so we should just print an empty space. Now, if we run our program, we can see that the board looks a lot more visually appealing than it did before. There's one more thing that we'll add to our program that will help polish up its look and functionality. We will clear the console output before printing the new board to the console in the game loop. We can do this with the system function. This is a built-in function that allows us to execute system-level commands as if they were typed into the system's command console. This will be another place where we could run into some minor compatibility errors, though. In Windows, the system command to clear the console is cls, while in Unix-based systems like Mac and Linux, the command is clear. So it seems like we can either make our program work in Windows or Unix, but not both. Or can we? It turns out there's a fairly straightforward solution to this problem. We can use something called preprocessor directives to selectively compile different code depending on whether some condition is met. We actually have already been using preprocessor directives in our code. For example, including a library is a preprocessor directive that simply copies and pastes code from that library file into our program before the program compiles. There are a whole bunch of different preprocessor directives that all do specific things before compilation. In this case, we want to use the ifdef directive. If we place ifdef_win32 into our code, then the compiler will only compile the code between that ifdef and the next endif directive if win32 is defined. This will allow us to only have our program execute the system cls command if we are running on a Windows system. If we are running on any other system, then we can add an else directive that will run the system clear command if we are not running on Windows. This solution is not without its limitations, however. When we compile our code, the compiler will give us an executable as its output. If the program was compiled on a Windows system, then that executable will run the cls command instead of the clear command, and will therefore not be portable to Unix systems, and vice versa. This means that we will need to build separate executables for our program for each operating system we want it to run on. In most cases, however, this is a trade-off that is worth taking, as building separate executables for each operating system is not too much of a hassle. Alternatively, if you know you are only going to be running your program on one system, you can just make the code work for that system only, which eliminates the issue. At this point, we have most of the fundamental parts of our Sudoku game built. We just need to add more features to our game that will make it even better. We'll continue in the next video by learning how to read and write from files stored on our computer's hard drive. This will enable us to save and load games, allowing the user to leave a game and come back later without losing their progress. Until then, feel free to play around with what we have already and let your creativity run wild. With the tools we already have, I'm sure you have lots of ideas for how to personalize your own version of this program. Feel free to share your ideas in the comments. Thank you for watching, and I will see you next time.